6.3, the technical model. Intro to numerical model. There are two different ways of looking at forces. Firstly, there is kinetics, which is the part which refers to the forces and what is a force. And this is a push or pull upon an object resulting from the object's interaction with another object. The other aspect is kinematics, which is the part which refers to the motion and movement. And the equation for this is mass times acceleration. There are different areas in which these can be measured. Linear motion, which is the idea of motion in a straight line, rather than being around an axis moving side to side. Angular motion is the idea of the object or person moving around an axis. This can be a fixed point or fixed axis, but it is motion around a point and projectiles, which is the study of how a ball or object travels, and it takes into account the horizontal velocity and vertical velocity to see the distance it will go. A numerical model is created by three main things. Firstly, it can be via literature and books, which is the perfect model, which is where, the perfect model is clearly defined by an author. It also can be an elite athlete, which can create a perfect model as the way they do things. So, for example, in tennis, a serve will be the perfect way to do it. And then finally, the internet, where where it offers different ways to do a movement in diagram form or in images. Advantage of the numerical model is that it's very specific to certain areas. It's very accurate and quite quick to complete for one individual. And it can also be very good for tracking progress in terms of how much you are improving if you do it every week, for example. However, it can take a long time for a large group, as everyone has three attempts at it to get an average, and there's a lot of numerical data to calculate from that. It has low ecological validity, as the force plates we use were indoors, and also you need to be a sports scientist or familiarized with the technology to use it to the best of its ability. So, forces. Isaac Newton was a physicist who created the three laws of motions of inertia, acceleration, and action and reaction. These can all be related to sport, to be in sport, and how objects and people moved. Force is measured in newtons and can be calculated by mass times acceleration, or as shown here, you can rearrange it, but it's shown as force equals mass times acceleration. Newton's laws. The first law is inertia, which can be defined as when an object is either stationary or moving in a constant velocity, won't change unless an external force acts upon it. For example, in basketball, if someone passes the ball, it will move in the direction of where they passed it unless something happens to it, like an opposition touching it and intercepting it. The net force will equal zero, as there is no change in motion and no unbalanced forces acting upon it. The second law is acceleration, which is when a force produced is directly proportional to the net force in the same direction as the net force, and it is inversely proportional to the mass of an object. And this shows how if a stationary or moving ball has an unbalanced force acting against it, how quickly does it move? For example, a tip-off in basketball, the ball is going directly upwards until one of the players touches it and moves it in an opposite direction. Then the third law is an action and reaction, which can be defined as for every action there is an equal and opposite reaction, which basically means when there is a force exerted in an object, the object gives a reaction, but it does depend on the mass of the object. For example, hitting the ball in baseball, the mass of the bat is more than the ball, so the ball will end up going in an opposite direction. But another example is jumping and landing. So when you land, you exert a force on the ground and it gives the same force back. But it obviously doesn't move as the ground is an immovable object. There are also 5 effects, which are rest, which have an impact on the force. These are rest to motion, which is when the object goes from a stationary point to moving, so there is an effect on the force exerted. Change in direction, which is when an object is moving one way and there may be some resistance to it going the other way. Accelerate and decelerate could affect the force, as either way the object is accelerating or decelerating. This will affect the force being exerted, as the ball is either coming towards you or going the other way, so it'd be more difficult to exert a force. And then finally there is the change in shape. So for example, in tennis, when the players hit the ball changes shape slightly when it comes into contact with the racket. And then obviously goes in the opposite direction. Then with forces, there is the impulse, which is the change of momentum of an object when the object is acted upon by a force for an interval of time, or it could be the average impact of a force. It is measured in force per second, and it's related to momentum, which is also known as how the movement of an object changes in the same vector. This could be relevant to basketball if someone was running down the court and it takes the mass and velocity of the person into account. For example, if they were running faster down the court, they would have a higher momentum. And if they were higher mass, they would also have a higher momentum. Stability and instability. Stability is the fact of how balanced you can be in the duration of your sport. And for an example is this in football. When you jump for a header, you are very unstable, as you're in the air and you have no connection to the ground. But if you are spread out marking your opponent and you spread your body out, you are very stable and difficult to push over. This is affected by a person's centre of mass, which is the part of body in which distribution of mass is equal. This can be usually found here on a man and here on a woman. This can change when a mass is added. For example, if the person is lifting a weight, when their centre of mass, when their centre of mass will change to where the new mass is no equal to the weight onto that. Next is the base support, and this is how the body makes connection to the ground. These are very often your feet, but in a sport like gymnastics, sometimes your hand may be the base of support, as you're balancing on a beam, for example, with them. For the box out and rebound, the base support needs to be strong, so you can block off your opponent effectively. But one of the strongest bases of support is obviously not in a sporting example, but is a tripod, as it has 3 legs, and it's impossible to push over. Then the line of gravity, which is an imaginary line which goes from the centre of gravity on a person directly down to the ground, and it shows how gravity acts upon a performer. Ways to increase stability are by lowering the centre of mass, and this will mean the performer has spread their mass out more, keeping their gravity line within the base of support, but also widening the base of support, as this gives more stability, as it will be harder to push them over horizontally. For the box out and rebound, the defender will need to get lower to the ground to change their centre of mass and increase stability so it's harder to push them over, as well as spreading their legs out to increase their base of support. The method of data collection. The particular sport being filmed can be in 3D or 2D when watching it back, for example, as a video in 2 dimensions, but it can also be captured in 3D by Vicon, which is a video platform where you can put spots on the performer, which gives an outline of their body on the screen, which is more specific as it shows the action in more detail. Digital images are how the images are shown in a computer, and with 3D imaging and the spots, the performer is shown on the screen with all the dots. There is also shutter speed and frame rate, which can affect the quality of the image. So if there is a higher shutter speed or frame rate, it will get the image more clearly. So for example, on the left, it had less frequency or frame rate than it did on the right, as the image is shown clearly. Physically setting up the camera can be very time consuming, to get it in the right position. There are four bits of criteria that need to be met. Firstly is the triangulation, which is making it perpendicular to the thing you are filming, so whether it is at the appropriate height. Then there is pan, which shows how wide the lens is showing and how far horizontally it shows. Then tilt, which is whether the camera can tilt up and down to show the movement in more detail without going out of focus, and what angle they can put the camera at. Lastly, the roll is whether it can rotate horizontally to help show the angle of a movement, for example with a joint or something. There can also be some errors with the recording. For example, the horizontal scaling may be where the camera isn't aimed at the right position, so hasn't been able to capture the action effectively. And there is also the perspective error. So wherever the camera is set up, it may not show the accurate representation of how it went. For example, filming a football match from the sideline may not give an accurate perspective. Also, for basketball, capturing any of the footage will be quite difficult, as this is a very fast-paced game and all the players are moving most of the time, so it will be difficult to focus on one individual, as they will always be moving, and it will be difficult for the camera to keep up, as well as staying in focus. We did some testing for ourselves on our performer, and this was to see how good they are at jumping from a stationary position using force plates at university. This may not have been as representative for the box out and rebound, because usually the box out has a step and then a jump to catch the ball, but this was from a stationary position. Also, we make sure the legs were at a 90-degree angle, so everyone had the same amount of time to exert their force to push themselves upwards. Firstly, some of the results were how much force they created. So that's the top left. My performer was participant number 8, and as you can see, they had a net force of 490 newtons, which is above the mean of 400 newtons. And I compared it to participant 8, who had the largest net force of 680 newtons. So both these performers are above the average, which shows they exerted the most force. For some reason, maybe because they had most motivation, or maybe they had the most experience. For example, they might have played basketball before, or they're used to doing something like plyometrics. The duration of the phase is how long it took. The mean took 0.5 seconds, and my participant took around the mean score, which was about. The mean was about 0.51. My participant took exactly 0.5 seconds. And this was because everyone was around the similar area. And yeah, it may depend on their weight and how quickly they came back to the ground. So if they were lighter, they were able to jump higher, and they came back down as well. The net impulse for my performer was around 250, which was above the mean. So this, yeah, again from before is also relevant to the momentum. So yeah, and also participant 6 was quite far above the mean, around 275 newtons per second. The velocity, power, and acceleration. So for this, my participant had about 3.5 of a mean velocity, which was much above the average, which was 3. This may have been because they were maybe putting more effort in, or they were just quicker to do the action than other people. Maybe other people were making sure that they were in the 90-degree angle to make sure that it was a fair test. Then for the acceleration, my participant had about 7 meters per second, which was 1 above the average, which may have been again because they were maybe trying to rush it, get the jump over with because they were nervous or something like that.